Okay, yeah, it is good now. So we have one more week before spring break. Okay. So after this week, we have next week and then our spring break. You have already gave one mid one. So there is another exam for mid two. Hopefully, it will be after the spring break. Not after spring break will be, and then it will be start till I think April, from April 3rd this week. Start till April 3rd. Okay, after spring break. Not the first week of April, maybe just the following week of April. We will go for the mid one. Okay, it will be hopefully it will be 13th of April. Okay, 13 April. 13 April, and we'll talk about in our next okay in next week as well. Okay, to confirm it. So you can think that it will be 13th April 13. Okay, Thursday. Hopefully will be the second meet. Okay, I'll also give an announcement. No worries. And then okay, then we'll decide the syllabus as well. In our next class, we'll decide the syllabus. Okay. Okay. Now, today let's okay. We can start now our regular session. Okay, let me share my screen first. I cannot share from in here. Let me share from my iPad. You can see my whiteboard. Okay. Now I think you can able to see the whiteboard things. Let me okay. Give me a minute. I didn't open the PowerPoint from my side that I already uploaded inside the module. Today we will learn the new section. It's called the thread. Okay, I just mentioned in our next last class that we already complete the processor management algorithms, and today we will start the thread. Okay, what is thread and how it works? Okay, in course it is advanced thread. In our today's class, we will talk about the thread. What is the thread and how it works? Okay, computer thread. It will take, I think, 2 class should be fine. We'll complete the thread. Okay, at some advanced level of thread. Okay, how a computer thread works. Okay. So till our last class, we talk about different process management or process management algorithm, how to schedule a process from RAM to CPU, and we learn algorithms like SJF, SRTF, LJF, LRTF, and then one is HRNN, and finally we also learn the round robin. Okay, round robin scheduling algorithm. This is very important. You will get some, of course, you will get some question from this round robin algorithms. Okay, this is very popular algorithms nowadays. Every operating system use this round robin scheduling algorithms. Okay, to be available this round robin scheduling algorithms. Okay, and next and today we'll talk about our one new topic is called the thread. Okay, thread. Okay, we didn't talk about this thread yet. Thread is related to the process. Okay, related to our process. Okay, before we start the thread, let's see again, just recap something from the process control block. Then it will be easy to understand that what is the thread and how it works. Okay, you already know about the process control block or PCB. Okay, process control block, PCB, process control block. So you know that in process control block, there is several parts. You also know, I showed you previously. There is in process control block nothing but a single process. Okay, single process. In a single process, what type of elements actually, what types of component inside a single process? This is the process control block. Okay, here is a one is called heap segment. Here's a heap segment or segment. One part is heap segment, another is stack segment. Stack segment. Another is data segment. Okay, data segment. Another is code segment. Code segment. Okay, code segment. Okay, code segment. These are the 1, 2, 3, 4 parts of a main part of a process. Okay, main part of process. Okay, this is heap segment. Heap, or in short, we also call it heap, also stack, and data and code. Okay, code. Let's see, you write a code in C++. Anyway, let's see, you write a code by using a programming language C or C++. Then what's you'll do? Your source code. You write your source code, and then you compile it. Okay, compile it. Compiler creates a machine code. Okay, machine code, and then you can execute or run this code. And then you can actually execute your code. Okay, so this code segment is nothing but this block after this compiler generating machine code. This is actually comes inside the code segment block. Okay, and what the data segment block contains you know already that in data segment, in your code, in your source code, you may define the global variable or also the static variable. Okay, static variable. Okay, these two types of variable, special variable. Global variable, you know that it needs to access from every function. Okay, also static variables, it needs to actually inside the code until it's actually finished, until your program is finished. Okay, it needs to align. This is static variables. Okay, so these two types of variable, usually if you define these two types of variable, it will be inside the data segment. Only this global and static variable will be inside the data segment. And your stack segment, what's its content? It contains very important things. Let's again recap some actually in details from this stack segment. How it works. Then we'll jump into the threads. Okay, stack segment, also we'll talk about the heap segment. Okay, these two parts is very important before we study the thread. Okay, this is a process control block. Process control block. Okay, or PCB. Okay, so now let's see what is the stack, what actually stack segment does. Let's say in your program you may have main function. Inside this main function, you define some local variable integer a, b. Okay, and then here you can also make a function called f1. Okay, and then f1 actually, let's say you have f1 body is in here, f1, f1 you define in this location. Also have f1 here is also may have some local variable like integer cd, okay. And then here you can make also one function call. Let's see in here. Then you'll go to then f2 you define, let's see in here f2, and then f2 also it may have some local variables this way, and then let's say till here, okay. So how your programs will work at first in main, and then this code segment is nothing but contains this let's say this code, okay, this line, fuse of line, okay. At first the main your stack segment will contains the function, all function and the local variables that you define inside the function, okay. Stack segment content, this is very important. Stack segment contains the local variable of a functions and the sequence of function call, okay. What is the sequence function call and how it works? Let's see how actually stack segment works. Let's see. It contains I mentioned that it contains the local variable. As you know that stack is nothing but last in first out, okay. Last in, if you know the stack, you may know last in first out. First out is stack, or in a short we also know about stack. About stack is nothing but LIFO, last in first out. Another is queue that stacks, and you also study in round robin algorithms. Queue is first in first out, okay. FIFO, queue is FIFO, and stack is LIFO. Means FIFO means which comes first will be out first, and LIFO means that which comes last will be out first, last in first out, okay. So how actually function call works? Let's say when your program executes, it will get the one function is called main. So main will be inside this stack segment, okay. Main, now main is inside this stack segment. Also here two local variable, also a and b will be also inside the stack segment, okay. And then after executing in here this function, okay, this function after actually call when you call this function, your program will actually jump to this function, okay. Will be jump to this function. When it jump to this function, will execute, then it will be inserted to the stack, okay. F1 function is in here. Also it has c and d, two local variable as well, okay. Will be inside this stack function. When also this line is executed, and that one will be executed. When there is a function call, f2 will be here, and then f2 will be also inserted in here, okay. Also it's also here, it will find some local variable x and y also will be inside the stack, okay. This is the stack. I talk about this part, okay. Stack part, okay. This is the stack. When you call the function, okay, call a function inside the inside your programs, okay. It manages the sequence of the function call. Now let's see how your programs will work. Your programs needs to execute which function first? Now f2 function first. After completing f2, it will return in here, then f1 will be complete, and then when f1 complete, then it will be written in this line, and then main will be complete. So it need to complete f2 first, okay. So when f2 completes its execution, then you see that it will remove from this stack segment, okay. It will remove from this stack segment. Now you can see that this comes last, should be out first, okay. This is why it is LIFO. Also you need to this is why this segment name also the stack segment, okay. And then when that one is complete, when f1 is complete, then what we will do, f1 will be written in main, then f1 also be out from this stack, okay. And then main will be executes and completes the execution of code, okay. This is how actually a program actually manage the function call, okay. Manage the function call by using the stack segment, okay. Stack segment, okay. Also stack segment contains the local variables. If this is a integer variable a, so inside this stack segment also it will takes the 4 bytes. Usually typically integer size is 4 bytes, so it will actually allocates the 4 byte data, 4 byte memory inside the inside the stack segment. Okay, local variables, the stack segment. Okay, uh, will be actually allocates memory inside the stack segment. Okay, this is the stack segment. Also, you know that stack segment works as the data structure stack. What is the data structure stack? Data structure nothing but the LIFO, last in first out. So here also stack segment works the data structure like LIFO, last in first out. But now comes to the heap segment. Okay, let's check this again, that how heap segment works. Okay, now what actually heap segment do? What it does, heap segment actually allow for this dynamic memory allocation. Okay, when inside when actually you need to dynamic memory allocations in your code, if you declare any pointers variables, and these variables needs to allocate memory during the runtime. When your program needs to allocate memory during the runtime, this memory will be allocated inside the heap segment. Okay, inside this segment. Okay, so let's say if you maintain a linked list, also linked list, and then any tree structure data, also there is kind of list tree structure data. Okay, amount of the pointer data, and any pointer data, this data will be allocated inside the heap segment. Okay, heap segment. Also, you know that LIFO work is similar as the stack works similar as the stack data structure. It's nothing but LIFO, last in first out, to manage the function called sequence. Okay, sequence of function call. To manage the sequence of function call, stack work similar as the stack data segment. Also, you may know that there is one data structure is called the heap data structure. It's known as the heap data structure. You may know about this heap data structure. You may know about the stack. Also, heap is little bit advanced level data structure. If you know these heap data structures, also if you have some idea, have some work with Python programming, there is how it works. Let me give you a quick overview that how LIFO actually heap structures data structure works. Okay, heap data structure is nothing but it contains a list kind of like this. Let's say 10, 5, 1, 2, and let's say 100. Okay, this kind of, and then a dot b equal a dot one function is called heapify in it. So then list or array will be the heap data structure. If you use this keyword, then it will be the actual heap data structure. It will be inserted to the B, let's say B, assigned to B. And when you b dot pop, then what it will do, it will actually return the minimum value, always return the minimum value. So it will return the one first, and then again if you b dot pop, then it will return the next minimum. 3 will be returned. Like this way it's work. Just rough idea. Yeah, you can study the heap data structure. It is very actually interesting. You can use that things. You can learn that things. Also, many interview for high tech. If you go for interview, invite to go for coding interview, some high tech company, they may ask you some question for a heap data structure. Okay, so this is heap data structure, but heap segment actually contains the dynamic memory in process control block. There is no relation between heap segment and heap data structures. Okay, you may think about if you learn the heap data structure, you may think about that heap segment in process control block may work like as a heap data structure. It is not actually valid. Stack works as like a stack data structure, but heap segment is completely different. There is no relationship between the heap data structure and heap segment. Okay, keep in mind. Okay, this is very important things. Okay, uh, always students actually get confused. Okay, they may think about, okay, heap segment may be similar as the heap data structure. It is not correct. Okay, heap segment is completely different. It's just a memory locations. It's allow the if your program needs some dynamic memory allocations, then this memory will be allocated inside the heap segment. Okay, as simple as it is. Okay, now let's see if you now let's see. Okay, let me make a new one new page, or let me clear that one. Okay, now let's see this. This is our process control block. Let me again I redraw it. This is the process control block. This is, I mentioned, this heap segment. Here is stack segment. This part is data segment, and this part is code segment. Okay, this is the PCB process control block. Okay, now we talk about the heap heap segment. Okay, heap segment actually allow to memory when your program need for dynamic memory allocation during the runtime. Okay, during runtime. Okay, so in your also one thing you need to know this. Stack data segment is static. This one is dynamic. Okay, dynamic. Okay, why it is static and why it is dynamic? During the when you write your code, source code, and then compiler will compile your code, and then you will get the machine code. Okay, machine code. Okay, now we can see that machine code will be in here, and then during the compilation time, how many function call, or how actually how much data is required for each text segment during the compilation time. Compiler actually decided. Okay, compiler actually decided, okay, this for this code it needs, let's say, 10 MB for or let's say 100 MB for this text segment. It is static and it cannot be changed. Okay, during the run compile time we decide this is text segment how much amount of CD is actually required. Okay, and for in case of heap segment, during the compile time, compiler actually doesn't know that how actually how much dynamic memory, actually how much data is required for the heap segment. During the runtime, your program can your process can know that how much amount of needed from the heap segment. Okay, during the runtime. So this is dynamic. Okay, it never be static. It's for heap segment. Okay, now let's see how you can access the heap segment data from this heap segment from your code. Here you have some code, also here some data, of course. Also there is stack segment. Stack segment is nothing, it contains nothing but function as well as the local variable. Let's say you write a function f1. You write a function. It's called, the name is f1, and inside this f1 function, you can declare a pointer variables, integer. Let's say a. Okay, integer a, you define a pointer variables. Let's say in case of C++, you can decide like this. I think it is like this, or it will make a integer variables. Okay, allocates the memory, or you can define an array as well. Like it will be new win 10. Okay, this is the two local variable inside this function f1. Okay, so f1 will be of course when this function will be called, I told you that f1 should be inside the some point of stack memory. So f1 will be in here. Also, it's local variable. Local variable star a, b, and star a. Okay, two local variables inside in here. So when you allocate the memory, I said that when you allocate the memory during this runtime, this is the dynamic allocation. It will allocate during the runtime. You know this already. You know that stack is when you sorry, pointer is a dynamic variables. Okay, during the runtime, when actually during the execution time, when new keyword will makes the allocations, the allocates the memory for this variable b or for this variable a. Okay, also here we already studied that this when it is dynamic memory, this value will be this value will be allocated from the heap segment. Let's say when a is executed, then 2 bytes, sorry, this integer, so 4 byte will be allocated from the heap segment. Okay, from the heap segment, but a is in here. So how you can access the value, whatever value you just next, whatever value you just assign inside this a, how you can access. Let's say you assign a value inside this a, let's say 5 or 4. Okay, 4 should be inside the heap segment. Okay, inside the heap segment. Okay, or if it is integer 10, so it will be the array like this. Okay, integer total 10 array 10. Okay, 10 segment, maybe 40 bytes will be in here. Okay, 40 bytes will be in here. Okay, this is for B. Also here you also assign some value as well, 10 value as well. Okay, let's see how you can access this value from the heap segment. Okay, your local variables is in here. Somehow a pointer a is in here. Also pointer b should be inside the stack segment. From this stack segment, how we can access the value from the heap segment. Okay, let's see. Oh, when you also before I actually talk about this, how you can access, one more thing I need to actually have mentioned that your programs, when your program actually executes, when it programs will execute, let's see, it will execute this line, steadily. Your code can directly access the stack segment, can directly access the stack segment from your code segment, whatever actually machine code generates by the compilers. From actually it is executed by the CPU. From this code segment, your actually CPU can access, or your code segment can access the stack memory, stack segment directly. Your code cannot access the heap segment directly. From here, your code cannot access the heap segment to fetch the data, to get the data. So how actually the code segment will get the data from the stack memory in case of dynamic memory allocation? Let's check. So while it makes this new keyword, you know that this value here, it will what it will do. It will new will return an address where actually this value is generated. Okay, and this memory is allocated. Let's say this memory allocated at the address number 100. Okay, so star a will be assigned to 100. Okay, 100. It will get the memory address, or in case of B, it will be the starting address. Let's say here array was starting address is 200. So whenever you make this array, so star B will be the 200. Okay, here it will be 200. Okay, it will actually store the starting address, the heap memory locations. Okay, where actually it allocates the array is allocates. Okay, allocates this memory. Okay, it takes this static memory, store the static memory in here. So this is why when you write your C program code, and then you hear that okay, the pointer variable store the address of a variables. Okay, this is the reason. Okay, if it is not a pointer variables, then it is just simply value. It is allocates memory inside the stack segment. Okay, in case of pointer variables, it allocate memory inside in the heap segment. So to get the data from this heap segment, your variables star variables or pointer variable needs to store the address, okay, to fetch the data from the heap segment. That's why you hear that the pointer variable always store the address of a variables. Okay, so here when actually it needs, your programs will ask the data from A, and from this your code will get the address of the heap segment, and from this address, actually your code will fetch the data and get the data. Okay, this is how actually your programs will be executed. Okay, by using the heap segment or by using dynamic memory allocation. Okay, so dynamic memory allocation, it can be, it depends on how many variables actually you define inside as a pointer. Okay, inside as a point, how many actually variables you define as a pointer variables. Okay, pointer variables will be all pointers variables, or also tree is kind of pointer variables. This will be allocated inside the heap segments. Okay, also one thing is that your code segment cannot access the uh, heap memory directly, but it can access the stack memory directly. This is one important point. Okay, you need to know about this. Okay, so do you have any questions or comment regarding heap and stack segment? Okay, so we can move forward. Okay, do you have any questions? Okay, let me wait. Okay, if you have any question, please message me anytime. Okay, no problem. Okay, so let's move forward. So what is the thread and how it works? Okay, so now let's see the thread. Already we know about the process. Okay, before we talk about the thread, let's see that let's see that what is the, we already know, we need to actually draw the memory. Sorry, PCB. Here is heap, stack, and data and code. Okay, this is the PCB or process control block. From here, you can see that let's check your code segment. Let's consider your code is, let's say, 10 lines of code. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, you write 10 lines of code. This is line 1 2 3 4 5 6 7 8 9 and 10. Okay, and then what's you do, this is the sequence of code you write inside your program, and then you write a one if else condition. Okay, if here in this, right, let's say in line number 6 you write a if condition. So if it is true, whatever the value is condition, if it is true, then it will execute the 7 and 8 number line. So yeah, 7 and 8 number line. Else your code will execute the 9 and 10 number lines. Okay, 9 or 10 number lines. Okay, so from here you can see that your code, either it can execute like one, of course, line number 1, and then 2, then 3, 4, 5, 6, and 6 if condition, if it is true, then it will execute the 7 and 8 line. 8 line. Also, in other case, if condition is false, then it will be execute the else condition. It will skip this 7 and 8 line. Okay. So what is the sequence? This is one sequence. This one probable sequence that your programs may actually run. Okay. This another sequence could be 1 and then 2, then 3, 4, and then 5 and 6. If its condition is false, then it will execute the 9 and 10. Okay, 9 and 10. It will execute in different sequence. Okay, there is this sequence. Okay, two different sequence. It can be. Of course, you know that it can be. Depends on the. Let's say this is one variables. You text you input from the user. C num. Also here this number is greater than 10. Then it will execute. And if it is not, then this line will execute. Okay. If it is 10, this line will execute. If it is not less than 10, this else will be executed. Okay. It can be possible. Okay. This is two different sequence of executions. Okay. Process is actually nothing but the sequence of execution. Okay. How your programs will execute, your code segment will execute. This is actually concept of a thread. Sorry, thread. This is a concept of a thread, the sequence of execution. Okay, here your code can execute in two sequence. So in your code there actually will be two thread. Okay, two thread will be available. Okay, will be available inside your code segment. Okay, inside your code. Okay, so thread is nothing but the different some sequence of execution. Now let's see. This is one process, and here is lines of code. There is lines of code. So this process somehow when it executes, when this process is executed, so it will execute these all lines. Okay, all lines. Okay, so and again you also open this project. Also again it will execute. Okay, from here from here you can see that by default every process is a single thread. Okay, single thread is available. Thread is nothing but the sequence of execution. So when you open a process, by default every process is single threaded. Okay, always keep in mind this topic. It is always single threaded. Okay, by default it is always single threaded, every process. Okay? Because at least one sequence is available when it executes. Okay, at least one sequence is available. So by default every process is single threaded. But here I just give a task. There could be multi-threaded process. We'll learn for the multi-threaded process as well. So before we study the multi-threaded process, let's explore some other concept from this actually process. Okay, process control blocks. Okay. So now you get some idea that what is the thread. Thread is nothing but some sequence of executions. Execution. Okay. Also give you one example as well. So when you open, let's say MS Word or PowerPoint. Okay. When you write a file, when you actually edit a file, and then you may need to go for actually some font change. Okay, font change. You can go for this font color change. Okay, then your MS Word or MS Office will make a create a one thread for font style. You can go for the save. So save is another thread. Okay, this is when you click the save button, another set of let's consider in here. When you open a MS Word Office, let's say, of course, heap is stack and then data, and then here is million lines of code for your MS Word, Microsoft Office. Okay, there is millions lines of code. Okay, when you save a button, So some sequence of lines will execute. And then when you actually change the font, then another sequence of code will be executed. And then when you actually when you go for actually some spelling check, then another sequence code will be executed. Okay, so you can see that a process may have several threads. Okay, a process may have several threads. So what is the advantage of several threads instead of several processes? We will now we'll discuss. Okay, now we'll discuss. It will be more clear. Okay, no worries about the multiple thread. We'll discuss in details in later. Okay, what is the multiple thread and how it's works. Now before we study the thread in details, so let me talk about the what are the types of a thread. Okay, we have two different types of thread. Okay, we have two different types of thread. You need to know about this. Two types of thread in your operating system. Two types of thread is available in your operating system. Okay, one is called user level thread, another is kernel level thread. Okay, kernel level or system level thread. Okay, thread, you know that we have some user process, also we have some kernel process as well. Okay, we have some user process as well as we have some kernel process. Okay, user process, that whatever your application you open, this is creates a user process. But whenever you whenever actually open a process, then there is a system call. Actually some function will be called. Okay, that function will be called from this operating system. Okay, then it is a system call. Some process will be some process will be created inside the kernel. Okay, inside the kernel of computers. Okay, also this process may have different types of thread. Okay, this thread is known as the kernel level thread. Also, we are now talking about the user process. So our thread, we are considering right now the user level thread. In our later class, we'll talk about the what is the difference between user and kernel level thread. Okay, no worries. Right now, you just know about this. There are two types of thread: user level thread and kernel level thread. User level thread is available for user process, and kernel level thread is available for kernel process. Okay. Now let's check that. Now let's check that what is. Okay. Okay. Now one more thing you need to know about this, okay, the two things I already mentioned, that user level thread and kernel level thread. Okay. Now let's check one example. Let's check one server example. Okay, server example, server. Okay, let's say one server, computer server, one server in here. Here is actually website is available. Website. Okay, website is available. This is the process is running inside the server for web application server. Okay, then let's say web application. Okay, one web application. It can be Facebook, LinkedIn, anything. Okay, and then of course several client will request the server for different to service his or him or her. Okay, let's say client X asks for a particular service, and then what it will do. This is a program. Okay, this is a program. Okay, this is a program, and then when it will client X will ask for a service. So to meet the client service, so your program will create one process. Of course, this is all inside the server. Everything is inside the server. We'll create the one process. We'll create one process. We'll create a one process P1. Let's say P1. PX. Okay, PX. This process will service the client X. Okay. Then let's another is client Y will also ask for a service. So your program will create another process to serve the client client Y. Okay, it is, let's say it is PY. PY will serve the client Y, and then let's say another process G. G will then another client will ask for this, nothing but the person, your computers, okay, your personal computers, okay. And then here in server will create another process PG, and then this process will serve the client G, okay. Now let's see, here is total 3 process. Here is your application code, here is your application code, service code, and so when it asks for to fulfill their requirement, your programs creates the process. Here is 3 client, but it could be million number of it, okay, at a time, okay, million of client. So you need to create the million of processes to satisfy the services, okay. Satisfy the services. Now what is the problem in here? Let's check it, actually look carefully that what will be the problem in here. Okay, you have a program, of course, when it's created process, it will what it will do. P1 also, Px contains the of course the heap and stack, and then data, and also code segment as well, okay. Also similarly, Py also contains the all 3 things, okay, all same things, okay. P, S, D, and C code. Also here also same. Here also contains the S, D, and C. Of course, C. Here, you know that code segment is very large. Okay, always it's large. Okay, when you make it compiler, you make it, code segment is nothing but it all lines of codes. Okay, lines of code. Okay, so code segment size is always be very big. Of course, very big. A kind of million lines of code will be there. You see that if your client X asks for a service, so to satisfy their service, you create a new process here. You create a new process. Actually, from here carefully that to fulfill the service for client X, you create a new process from your code. You just execute in a order, in some order, okay, from your code. When client Z also X also asks for a service, also you make this same code segment. It's also copy the same code segment here in 3 different, for these 3 examples, okay, for these 3 clients, okay, 3 code segment, just same copy, just their execution will be the different, okay. Their execution sequence will be different to serve to fulfill their requirement, okay, to fulfill their requirement. Let's say when you actually open a Facebook, your homepage, my homepage, and your friend's homepage is always different, okay. Just Facebook, when user request, their homepage is different, means that different sequence of execution of code. Here also another person for different sequence of execution of code, another person for different sequence of execution code, okay. You see that what you do here, you just make the same code for every process. Also this part is very large, okay. Here is, I give this example for 3 clients, it will be millions of clients, over millions of clients, okay. Then what is the problem in here? Your server will be actually will be memory overflow problem, okay. It may not have enough memory, okay. It will be the memory issue, okay, because millions of process, okay. Also every process contains the code segment, so there will be definitely there will be a memory issue, okay. And then another thing is that here also another important point, here is one process. So what you need to do to serve these 3 clients, at first it will serve, sometimes it will execute the process px, and then it will switch to process py to serve the process person y, and then it will again switch to process pz to serve the client g, okay. Again, also client asks for anything. Again, it will be the context switch to process P1, PX. Okay, that is there is one here is you see that process to process change is called, you know, that it is called known as the context switching. Okay, context switching. Okay, context switching. Okay, context switching when you actually jump one process to another process, when your CPU asks for one process to another process, when actually need to go for one process to another process. For context switching, you need to go for kernel call, something to call a function from operating system kernel. It's kind of like this. If it is OS, this is the kernel, the major parts, and then for context switching, always needs to call from some function from kernel, and then again back to the user mode, and then again for context switching, again ask for function for kernel, again back to user mode, kind of like this. So this system call actually it takes actually long time. Huh? It takes long time. So when you go for this context switching, frequent context switching, there is one issue for it needs a long time, okay, to execute, okay, to serve a client. Okay, so another problem is, of course, the memory issue. Same copy of code for every process. Another is called the context switching. Okay, you need to always switch one process to another process. This is the context switching issue. Is another context switching. Okay, context switching is another issue. Okay, so these are the two major problems. If you think about this server programs. Okay, so how we can solve this? Here you can see that the your program is same. Your program is always same, but depends on the client. Execution is different. Okay, execution is different. So you can think about that without creating new process, your operating system can create the new thread for every client. What it will look like? It will look like this. So when it will be the same code. Let's say this is a heap segment, this is stack segment, this is your data segment, and this is your code. Okay, code. Okay, then what it will do when client A will X will ask for this data, then it will create a new process. First, it will create a new process, and then what it will do? It will serve the client A by this sequence, by executing your code this sequence. Okay, when client Y will actually send a request, instead of create the new process, what you can do? Your operating system can create a new thread for Y as well. That will, let's say, execute your code in this sequence, and then G will ask for the service. Let's say your operating system need to execute this code in this sequence. Okay, in this sequence. Okay, here you can see, if you follow this formula, what you'll do? You have only one single process, but you can fulfill the request for every client. Okay, every client. Only is you need to change the sequence of executions of your code. Okay, you need to change the sequence of execution. Okay, this is how what will be happening here. So you see, you can, there is actually there is no new process when new request comes on the single process. So there will be the no memory issue. Okay, only one process, just execution sequence will be the different request. Okay, there will be the no memory issue. You can solve. Another thing you can do, you can for context switching. Context switching happens between one process to another process. Okay, P1 to P2. Okay, here is only single process. There is no context switching. depending on the client request, only the execution sequence will be the change. It is in a single process. Okay, so there will be the no context switching overhead as well. Okay, your operating system don't require to go for call to the kernel and then change the one process to another process, and then again actually back and again ask for this request call to the kernel function, and then again change back to the previous process. Okay, you don't require to do this. There is only one process, and just depending on the client request, you just a sequence of execution is different. Okay, so you can remove the context switching overhead as well. Okay, if you consider the thread concept. Okay, instead of process. Okay, this is the major benefit for using if you use the thread. Okay, where it is applicable. Okay, so actually here is not only a single thread. Here is, you see, sequence is different. So of course this is multi-threading process. Okay, multi-threaded process. Okay, multi-threaded process. Of course this is a multi-threaded process. Okay, if it is of course a process can be by default a single threaded by default. Of course every process by default, I showed you then previously P1, P2, PU, PX, PY, and PZ. Okay, every process, depending on the request, if you created the new process, every process they have some sequence of order of execution. So whenever you create a process, by default there will be at least one thread. Okay, at least one thread. So every process by default is single threaded, but here you see this process contains the several threads. So it is known as the multi-threaded process. Okay. So do you have any questions or comments regarding the thread? So far we don't learn till now we don't learn regarding the multi-threaded process. Okay. So this is the concept for multi-threaded process. Actually, how it works, multi-threaded process. In a single process, when several threads is available, it's nothing but a multi-threaded process. And in our next class, we'll learn the how you can implement the multi-threaded process. You know that in multi-threaded process, some part should be the common. Okay, code segment is common, and this part should be actually you may think about this common part for every users. Okay, we need to know about this. Okay, which part should be the common for every users. Okay, here you can see this code segment is common for this every user access the same code segment. We need to check this. Can data segment access by the every user? Can data stack segment can be accessed by this every user? Can heap segment can be accessed by this every user? Okay, we'll check this in our next class. Okay. Okay, before we go, do you have any questions or comments? Okay, if you do not have any questions, we may stop here and see you next class, or next class is next week. Have a good weekend. Okay, see you.